Now I will show you how to fit this model here, but using the reliability that the authors reported for child self-esteem and foster care burden and preparation support received to adjust for the measurement error of these three observed variables. Okay, so here I have the model. It starts with the measurement model for the original measurement model, which the variables that had more than one indicator. Now, I added the single indicator latent variable. So I add the PFP, you know, and as a measure of latent PFP. So for the latent variables with single indicators, I just put a L in the front of the variable name. So this is latent PFP measured by PFP. Um, so with this variable here, preparation support received now becomes a latent variable with one indicator. Latent self-esteem measured by self-esteem, latent FCB measured by FCB. Now, de facto loadings for these indicators, they have to be set to 1 because you have only one indicator. But AB Plus does that automatically. So you'll see the de facto loadings. AB Plus put de facto loadings as 1. Now you also have to set the residual variances. And this is where you use the reliability. So the residual variance becomes 1 minus reliability times the variance of that variable. So in the paper for PFP, the authors report Chromax alpha 0.9, a standard deviation of 13.54. So if you take 13.54, square it to get the variance, and then times 1 minus 0.9, so times 0.1, you get this number here, 18.333. And that's how you get the value you need to set the residual variance to. So we did that for self-esteem and FCB as well. Okay, I added the variance of age here just to make sure that the number of degrees of freedom meet the previous model. Like I'm just working with the defaults. This is something that Amos would estimate, but M Plus doesn't. But I'm estimating so the results are consistent with what the author did in Amos. And then the structural model. Now, the only difference here is that where there was PFP in the original model, I replaced by LPFP, latent PFP. So like here, this is PFP, now becomes a circle, and the latent variable with one indicator is latent PFP, but still has the same arrow here. So I did that, like I have latent PFP as a predictor here, latent self-esteem here, latent FCB here, and again, latent self-esteem here, latent FCB. So the model is the same as before, except that for these three variables, I used the reliability to adjust them for measurement error. So because of this model here will have exactly the same degrees of freedom and exactly the same fit as the original model. Because you see, I didn't simplify the model at all, like because every parameter I added was fixed. So that doesn't fixed parameters don't change the number of parameters estimated by the model, right? Because they're all fixed to set values here. Same thing with the factor loadings. This factor load is all set to 1, right? So you get exactly the same degrees of freedom and you get exactly the same model fit. The only difference is that now these reliabilities here will change the parameter estimates, right? So this adjustment is for reliability, is to improve your parameter estimates. It's not to improve your model fit. Okay, I will run this. And note that I got exactly the same degrees of freedom as before, 16, exactly the same chi-square and the same fit indices right now. But what I would expect is some of these coefficients here to be different, right? So let's look at what the one that is the least reliable. So the least reliable is FCB here because the reliability is 0.74, right? The parameter that is affected by FCB, we have here the direct effect of FCB on CLBP, which in the model is this one here. FCB is foster care burden on child's emotional behavior. So let's look at the original and the new value, right? So you open here. Before adjusting for unreliability, look at the standardized results. The effect of FCB on CBP was 0.412. Okay, now let's look at what it is after you adjusted for unreliability. Going to the standardized results. Here. So now the effect of latent FCB on CBP is 0.508. So notice that it increased because I removed some of the unreliable part of SFCB, right? So that's the benefit of this adjustment. It's to get more accurate effects, direct effects. Okay, well, that's it.